Okay, good morning, good afternoon, or good evening. So, last time we discussed yung Taylor series expansion, including yung special case niya, which is the Maclaurin series expansion. So, pinakita natin from before yung mga diniscuss natin na infinite series and even yung mga series of functions, no? And we have shown na any function f of x na may continuous, as long as meron siyang continuous along a certain interval, let's say a and b, pwede nating i-represent ang ating mga functions as an infinite series, which is a good way for, ano din, diba? Yung example ko is how to calculate yung mga values ng mga trigonometric functions, exponential, kasi di ba hindi naman yun explicitly defined sa mga computers. So yun. So now we will move on to a more general type of parang series na rin. Of course, yeah. Tawagin nating power series. So power series siya kasi it has parang sum siya ng mga terms na increasing powers of certain variable, let's say x. Okay? So the power series is a special and extremely useful type of infinite series. So ito yung form niya. So we have f of x is equal to a sub 0, a sub 1x, a sub 2x squared, a sub 3x cubed, and so on. So makikita nyo, pataas ang pataas yung powers of x. So here you have x raised to 0. So x raised to 1, 2, 3, 4. And then yung ating mga coefficients are just ano siya, per term. So first term, 0, second 1, 2, etc. So ito yung general form niya. So summation of a sub n, x raised to n from 0 to infinity. So constant lang yung mga a sub n natin. Okay? So now how do we define the convergence of a power series? So similar sa mga nag-discuss na natin, we can test for the convergence. Since power series siya, mas madaling gamitin ang ratio test. So using ratio test, we just have to take the limit of a sub n over a sub n plus 1. A sub n plus 1 over a sub n. So in this case, okay, malilito dahil may a sub n na tayo dito eh. Yung mga dati kasi ginamit natin are just for numbers. Now we have a function na, or let's say polynomial. So generally, basta you can express this as u sub n eh. So yung magiging ratio test mo is u sub n plus 1 over u sub n. So ganun lang gagawin mo. Since generally power series could be alternating, we have to take the absolute value. So to test for the convergence, take the limit of a sub n or u sub n plus 1 over a sub n, over u sub n, sorry. And then as n approaches infinity. So since ano naman ito, powers lang naman siya. So you have maka-cancel yung x raised to n. Matitira dyan ay, kasi ito ay x raised to n times x. So now we have the limit of absolute value of the coefficient a sub n plus 1 over a sub n times x. Ngayon, less than 1 kasi ito yung dito criteria natin for convergence. So this expression should be less than 1 in order for the power series to converge. So since yung x is just another parang parameter, pwede natin gawing limit ng a sub n plus 1 over a sub n times absolute value ng x should be less than 1. Okay, so we can, as n approaches infinity. So since wala namang dependence yung x sa n, as we have seen here, pwede natin ilipat sa kabila. So now, magkakaroon tayo ng ganitong expression. So ibig sabihin yan, kailangan less than 1 yung limit ng coefficients mo. Less than 1 over absolute value of x. So dyan mo makikita kung ano yung magiging valid values ng x. Tama? So pwede nating palitan lang para hindi kayo malito. Let's let absolute value of x equal to r. Some range r. Okay? So para mag converge, ibig sabihin yan, dapat yung 1 over r natin should be less than 1 over absolute value of x. So pwede nating paglipat, manipulate natin. We will have absolute value of x is less than r. So, or, since absolute value siya, is between negative r and r. Okay, so yan yung tinatawag nating interval of convergence. Okay? So let's have an example para malinaw. So test for the convergence of the function below. So we have the exponential function. So previously we have written yung Maclaurin series expansion niya. And this is easily done. So pwede nyo i-recall na lang doon. We have 1 plus x squared over 2 factorial plus x cubed over 3 factorial and so on. So ang general form niya is summation from 0 to infinity ng x raised to n over n factorial. So in this case, kung titignan niyo yung general form ng power series, yung a sub n mo is 1 over n factorial in this case. Kasi lagi namang naka-fix yung powers of x. Okay? So let's use ratio test. And we have nagawa na natin yan before. So, pero let's look at this example. So, lalagay mo lang ng plus 1 lahat ng n and then divide the original by the original general form. So, ito yan. So, magka-cancel dyan yung x raised to n. So, pakita ko dito we have x raised to n times x over n plus 1 factorial times mari-reverse yung yung fraction sa baba, ganyan. So now we have yung x raised to n times x over ano mang pwede mangyari dito. Express natin yung factorial. So n factorial, n plus 1 factorial is n plus 1 times n factorial times n factorial over x raised to n. So makakancel ito. Makakancel din ito. So now we have x over n plus 1. Since absolute value siya, you just have to write it like that. So ito na yan. Okay, so ang ating criteria for convergence is less than 1. So yeah, so ganun lang siya. Express natin, lipat natin x sa baba. We have the 1 over r. And since we have, kung ikukunin natin yung limit as n approaches infinity, magiging 0 ito. Meaning, 1 over r is 0. So, kailan ba magiging 0 yun? Kapag yung r mo is extremely large. So, in this case, is infinity. So, ang ating interval for convergence is negative infinity to positive infinity, or we can say all set of real numbers. Okay? So, ibig sabihin niya, ng exponential function is valid everywhere. Which is true, kasi ito naman talaga yung natutunan natin kahit nung algebra pa lang. Diba? So, malinaw yan. Okay. So, let's move on to another subsection for this particular section. So, ito yung uniform and absolute convergence. So, na-discuss na rin ito before, diba? Doon sa ating chapter 1. Ngayon kasi, mas detalyado tayo. We are dealing with power series na. Okay? So, ito yung mga kailangan nyo tandaan. So, if a power series has been found to be convergent, so ito na yung interval of convergence niya, then it will be uniformly and absolutely convergent in any interior interval. Let's say negative s to s, okay? Where s is a subset of r. So, halimbawa, meron kang range na ganyan, negative r to r. Kapag kumuha ka kung alam mo yung series mo ay convergent within this range, if you have a smaller range, let's say negative s to s, convergent pa rin siya dito as long as kasama siya doon sa, as long as subset siya no mas malaki mong interval. Okay? Of course, if it goes beyond that, ibig sabihin, hindi na siya convergent or you cannot say necessarily na convergent siya doon. Okay? So ito, we have the M test. Since this is a German word, I think this is pronounced Berstra M majorant test. Okay. If we construct a series of numbers, so this is similar to M test then. Let's say series of numbers, M sub I, okay, sum from to infinity. And if you compare yung mga terms, let's say M sub I is greater than or equal to the absolute value of U sub I of X for all x in this interval. Okay? And kung convergent yung series of numbers natin, then uniformly convergent yung u sub I natin in the same interval. Okay? Huwag kayo malilito, no? Medyo wordy kasi kapag mga mathematical definition. Kaya pwede natin maipakita rin sa mga examples, right? Ang sinasabi lang nito is actually basically comparison test. Yung mga, kung meron kang series of numbers na convergent, and kung may papakita mo na yung mga numbers na yun ay mas malaki kumpara doon sa, let's say, series of functions mo for all x, ibig sabihin convergent. This is essentially comparison test. Okay? Huwag kayong ma-overwhelm doon. Medyo wordy lang at saka medyo technical yung definition. Pero that's how usually yung mga mathematical definitions are. Okay? So, since we have specified absolute values, ibig sabihin, absolutely convergent. Okay? Tandaan nyo yun, ha? Sorry. Kapag kukuha ka nung tinetest mo yung absolute value ng isang series at nakuha mo na convergent, that's also called absolutely convergent. Alright? So, if you're able to show na uniformly convergent siya, and ang ginamit mo rin na absolute value, so uniformly convergent na siya, absolutely convergent pa siya. Okay? So, let's continue. So, tandaan nyo rin, we have to check for the continuity kasi we are dealing with function na, di ba? So, kung yung bawat terms daw, halimbawa, u sub n of x is represented by this, we have a sub n times x raised to n is a continuous function of x, and yung function natin, represented by the power series, converges uniformly for this range, yung mas maliit sa r, no? Then f of x must be a continuous function in the interval of uniform convergence. So kung continuous yung bawat terms mo within the same interval, yung buong function mo ay continuous din. Okay? So now let's talk about differentiation and integration. So if yung terms ng ating power series and yung buong power series natin ay uniformly convergent, then we are sure that differentiated series is also a power series. So pwede kasi tayo mag-derivative kahit summation. So kung ito ay continuous or uniformly convergent, kapag kinuha mo yung derivative niya, it also will give you a continuous function and convergence then. So if this particular power series has a radius of convergence or yung convergence of interval convergence, same lang siya ng nung convergence interval nung original. So kung ito ay convergent from negative infinity to positive infinity, kapag yun ang derivative niya, convergent pa rin siya with the same interval or in the same interval. Okay? So of course, may mga kailangan natin introduce, no? So the new factors introduced by differentiation or integration does not affect either the root or ratio test. So kasi kapag nag-differentiate ka, mababawasan yung exponent, di ba? Magiging x raised to n minus 1 yan. Then magkakaroon ka na n minus, n lang. Okay? So, n times x raised to n. Okay? Hindi naman siya makaka-affect sa ratio test natin kasi you can still test the convergence and will give you the same. Okay? So, ibig sabihin nun, ang power series can be differentiated or integrated as often as desired. So, kahit ulit-ulitin mo. And within that, of course, that's the limit, no? Kailangan nandun sa same uniform convergence. So, example, if you have the function f of x, and if f of x can be represented by this power series, if you take the derivative with respect to x, it's the same as taking the derivative of that infinite series. So, since constant ang isabihin mo, you can just act the differentiation doon sa x raised to n. Okay? So, magiging siya ganito. Alright? So, kung mapapansin nyo, yung term natin nagsimula sa 0. Now, when we differentiated, we have to start at 1. Kasi nag-adjust na yung series natin dahil sa differentiation. Okay? So, now if you're using ratio test, you just have to take the limit of the absolute value of the higher order term, n plus 1, divided by the original term. So I will not show this anymore. Then yun lang siyang gawin. So you have n plus 1 times a sub n plus 1 x raised to n. Naging x raised to n kasi mag-add ka ng isa dito, diba? So n minus 1 plus 1 is n. Then divided by n, a sub n, x raised to n minus 1. And ito yung matitira. Okay? So if we take the limit, so tandaan nyo, yung x, huwag nyo kakalimutan, should be, ililipat mo sa kabila, so magiging ganito. So this particular limit should be less than 1 over absolute value of x. And of course, if we let absolute value of x equals r, then we have this limit of conversion. So ibig sabihin, convergent din siya with at the same interval, negative r to r. Okay? Which is true. Kasi pinakita natin before na ang power series has an interval of convergence negative r to r. Okay? So yan lang yan. So napakita natin na kahit kung yung pa yung derivative nun, you'll still have the same interval of convergence. Okay. So let's have an example para malinaw. So let's take the derivative of sine of x with respect to x. So tandaan nyo, ang derivative ng sine x ay cosine x, diba? So, but let's use the power series form ng sine x. So doon sa previous section natin, 2.1, we have shown yung Maclaurin series expansion ng sine of x. So, well, ang Maclaurin series ng sine of x is also power series. So that's the power series form. So that if we take the derivative of sine of x with respect to x, we'll have the derivative of itong term ng sine. Ang sine x are just the odd numbers, no? So we have x over 1 factorial minus x cubed over 3 factorial plus x to the 5th over 5 factorial, and so on. And tandaan nyo, alternating series siya. So plus, minus, etc. And we have to take the derivative. So since ano lang naman siya, constant lang yung mga nasa denominator, we just have to deal with the numerator. So derivative ng una is just 1. Next, we have 3x squared over 3 factorial plus 5x to the 4th over 5 factorial, and so on. Okay? So kung mapapansin nyo, you have to divide. So ito magiging 3. This is 3 times 2. May matitirang 2, no? 2 factorial, sorry. Mawala yung 3. In this case, we have 5 times 4 factorial. Mawala yung 5. Ito na yung 4 factorial. So now we have 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. And this is essentially or exactly cosine x. So now we have shown, hindi nyo na kahit no, well, tandaan nyo naman ang derivative ng sine x ay cosine x. Now we have shown that by using the power series form, no, sine x, we were able to derive the answer, which is cosine x. Okay? We can also do this using the general form. Yung ginawa kasi natin is the terms. Hindi natin isulat lahat ng terms, pero using mathematical induction, we were able to show na tama naman. But now, let's use the summation form. Okay? So the summation form for sine x is just this. So we have negative 1 raised to n times x raised to 2n plus 1 over 2n plus 1 factorial. So tandaan nyo, add numbers to, no? Okay? And then, makikita nyo, we have to act the differentiation dun lang sa x, which is x sa may, sa may variable lang. So we have x raised to 2n plus 1. So, mangyayari, we have 2n plus 1 times x raised to 2n. Okay? Kasi binawasan natin isa. And then, we have to keep this as the same because constant lang siya. So now, ano mangyayari? We have 2n plus 1 over 2n plus 1 factorial. Okay? So, well, this is simple. Express lang natin yung factorial sa baba. So we have 2n plus 1. Tapos mabawasan mo ng isa yung buo. Right? So now you have 2n factorial. So makakancel yung 2n plus 1, matitira is 2n factorial. And this is exactly the general form for cosine x. Okay? So ganun lang siya. So let's do the other way around, which is, let's take the derivative of cosine x. So without doing this, we know na ang derivative ng cosine x with respect to x is negative sine x. So let's show that using the two methods above. So let's use the terms. So let's take derivative. So ito yung a few terms na ang cosine x. And if we take the derivative, we'd have this. So, well, ang derivative ng 1 is 0, wala na yan. So now we have derivative ng x squared over 2 factorial, or negative x squared over 2 factorial rather. So magtitry negative pa rin. Then 2, bababa. Bawasan mo na isa, magiging x lang. And still 2 factorial. Similarly, the next one would be 4 times x cubed over 4 factorial and so on. So, pwede mong i-factor out yung negative. Then you have this, which is the same as negative sine x. Now, by using the summation form, similar lang yan. So, we use the general form for sine x, cosine x. And then, act the derivative with respect to x dun sa x raised to n lang. X raised to 2n. So, now we have this. Okay? So, babalik ka lang din sa add terms. Okay? So, tandaan nyo, we start the summation here sa 0. Kasi we just follow yung nasa dito, no? Pero if you use a trick, pwede ka mag-change kasi ng index tawag dito. So, if we change the index from 1, mag-add ka, mag-add ka dun sa n. Sa n, hindi dun sa buong 2n plus 1. So now you have, let's say, change from n to n plus 1. So papalitan mo yung n lahat ng n plus 1. So magiging siyang 2 times quantity n plus 1 minus 1, ha? Hindi yung buo. So yung n lang yung added mo. So now you have, sa baba, ganun din. 2 times quantity n plus 1 minus 1. So now you have, matitira dito ay 2n plus 2 minus 1 is 2n plus 1. Ganun din sa baba. Okay? So this is, and huwag niyo kakalimutan yung negative. We have the negative here. Okay? Right? So wait. Yeah. Okay. So we have, this is for the whole sine x. And since may negative tayo kanina, you have to keep that. So that is negative sine x. Okay? So yan ang napakita natin how do we differentiate yung mga series in terms of mga few terms or even the whole summation general form. Okay? So let's talk about uniqueness theorem. So ano ba ibig sabihin nun? Let's show na ang power series is unique. Meaning, kapag meron kang given power series with some interval, kailangan hindi siya pareha dun sa or iba pang klase ng series, no? So let's consider this function. Halimbawa, if you can show that f of x is equal to the infinite summation of a sub n, x raised to n, within negative r sub a to r sub a, and then if you can also write it as this infinite sum of b sub n, x raised to n, and within the interval negative r sub b to r sub b. So this is the same function. We are just trying to show kung parehas nga ba talaga. Alright? So ibig sabihin yan, yung a sub n natin at b sub n are just equal. Tama? So let's try to use yung ganong klase ng definition. So let's equate them. And then let's have this particular interval. So where r, so pinalaki natin interval, no? Kumuha tayo ng bagong range. So where r is the smaller of r sub a and rb, kung alin man yung mas maliit. Okay, because we don't know, pinakita lang natin these are arbitrary values. So we can set x is equal to 0 para madali lang, di ba? So we have, kung 0 yun, magiging 1 lang. So we have a sub 0 is equal to b sub 0. Now if you take the derivative, ganito lang yung derivative nung una, ito. Then derivative nung ikalawa, which is this one. So magiging lang, no? Bababa mo lang yung exponent, then mabawasan mo na isa, and gano'n lang din. And then let's set x as 0 again to eliminate all the yung mga ibang terms. Magiging a sub 1 is equal to b sub 1. Tama? Kasi papalitan mo lang naman ng 0 ito, magiging 1 lang. Wala. And then, yeah, you can, sorry. Okay? So, repeating yung mga processes na yun, we can show na ang a sub n is definitely equal to b sub n. Meaning, the same lang or nagko-coincide lang. So, we have shown that the power series representation is unique. Meaning, wala siyang kaparehas. Okay? So, this means that, bakit ba importante ipakita natin na unique? Ang ibig lang sabihin nun, we can generate yung mga coefficient. Kasi ang power series is just a sub n x raised to n, di ba? Ito yung pinaka-common sa kanila. Yung nagkakaiba lang sa kanila is yung a sub n, kung ano mang klaseng function yun, di ba? So for e raised to x, ang coefficient natin is a sub n is equal to 1 over n factorial. Tama? For cosine x, ang ating coefficient is 1 over 2n factorial. Diba? So, ibig sabihin nun, we can generate yung mga coefficient. Okay? So, if we write, halimbawa, this particular series, so, kahit hindi nyo tandaan, or kung nakalimutan nyo na, this particular term is actually from exponential. Tama? So, halimbawa, we have this particular expression, we can show na yung a sub n natin is just equal to the nth derivative evaluated as 0 over n factorial. So, yan yung pag-generate ng coefficients. Tama? Okay? So, halimbawa, you have an infinite series. Kapag tinanong ka, what is the 17th coefficient? Definitely, para makuha mo siya, you have to take the 17th derivative evaluated at 0 over n factorial. So kung ang question is e raised to x, no? And what is the 17th coefficient? Madali lang kasi ang e raised to x, kahit i-derivative mo ng paulit-ulit, still e raised to x. So magiging lang siyang e raised to 0 pa rin kasi i-evaluate mo sa 0 over 17 factorial. So yun lang yung coefficient na. Madali. Of course, that is for e raised to x. If you have cosine x, kailangan mo pa ulit-ulitin yun, no? So, alam mo naman na ang cosine ay nagpabalik-balik lang sa sine cosine pag dinamihan mo ng derivative. So, kapag add, babalik ka lang din sa cosine. But you have to take note kung ilan. Tapos kung negative ba. Tama? Okay? So, let's have an example. So, evaluate the limit of 1 over cosine x over x squared. This is, as x approaches to 0. So, this is definitely one of the few examples na tinuturo sa calculus, lalo na kapag nagtitake ng limit. This is what we call parang indeterminate kasi nagiging 0 yung denominator natin. One thing na we do here, mangyayari kasi dito pag pinalitan mo ng 0, nagiging 0 over 0. And this is indeterminate. What we do here, usually sa calculus is L'Hopital's rule. You take the derivative, paulit-ulit hanggang hindi na maging indeterminate. So, well, that's for those method. But since we're dealing with infinite series, we just have to use that. So, pakita natin. So, in here, we can show na yung cosine x has the infinite series equivalent na ganito. So, we have 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus so on. Okay? So, dahil, nasa baba ay x squared, we just divide everything by x squared. So, ano mangyayari? Sorry. Huwag na nakalimutan, mag-cancel to. So, divide everything by x squared. So, matitira is ganito. So, magiging 1 over 2 factorial minus x squared over 4 factorial and so on. So as you can see, lahat ng mga susunod na terms nasa taas yung x. Meaning, kapag pinalitan mo ng 0 yon, magbabanish yung mga nandito. 0 na. And matitira na lang sa'yo ay 1 over 2 factorial, which is equivalent to 1/2. And this is exactly what you get if you use L'Hopital's rule. Tama? So yan. So without using L'Hopital's rule, ipakita natin na may limit talaga. The limit exists. Yun nga lang, you have to know yung power series expansion niya. Okay? So let's move to another subsection. This is called inversion of power series. So tandaan nyo pa ba yung mga inversion of function? So how do you get the inverse of function? Yung ginagawa natin, pinagpapalit natin yung domains. Tama? So ang inverse ng function is usually, pag kinuha mo yan, is a mirror image along the x equals y line. Okay? So halimbawa, if you have a, suppose we are given the series, halimbawa, y minus y sub 0 is equal to a sub 1, x times x minus x sub 0 plus a sub 2 times x minus x sub 0 squared. So makikita nyo ay ito yung coefficients. And then yung ating power is this. We have the quantity x minus x sub 0 and then tumataas lang yung exponent niya. So ito yung general form niya. Okay? So this means that we are given y minus y sub 0 in terms of x minus x sub 0. Well, essentially, you can look at it as parang linear equation, no? So, well, sa unang tingin lang, kung hindi power series to. So, in some cases nga, paano natin i-express naman yung x minus x sub 0 in terms of y minus y sub 0? Bakit ba laging nilalagyan natin ng ganito? Well, y sub 0 could be both 0. Yung x sub 0 natin, y sub 0, pwedeng 0 lang yan para mas madali. Pero we can deal with the general form. So we just write this could be any number naman. Okay, para lang mas ma-generalize natin yung expression. Okay? So in order to do that, let's write x minus x sub 0 as an infinite series then. So similar lang dun sa isa. Okay? So in order to get the inverse, let's substitute yung value ng x minus x sub 0. So to here. So papalit natin yung buong ito. Okay? Dito sa expression natin ng x minus x sub 0. So what we have is, so ang gagawin natin is, we have this whole expression. And since we are given the y minus y sub 0, like this, papalit natin itong buong to dito. So now we have this big summation. X minus x sub 0 is equal to sum from 1 to infinity of p sub n times sum from 1 to infinity of a sub n times x minus x sub 0 raised to n. Kasi may raised to n pa dito. Okay? So let's expand. Medyo mahaba, no? Kasi titinan nyo muna, kapag 1 yung b, okay, b1, expand mo ba itong kabila? Okay? For b equals 1, for n equals 1, we have b sub 1 times y minus y sub 0. So sa original muna, no, ito. Plus b sub 2 times y minus y sub 0 raised to 2 and so on. And dito sa kabilang side, we have b sub 1. Tapos magiging a sub 1, x minus x sub 0. Tapos magiging tuloy-tuloy lang to, a sub 2 times x minus x sub 0 raised to 2 and so on. So pagkatapos may sulat lang yun, infinite to, we have to go back here. Kasi 1 pa lang yun, we have b sub 2 na here. Then ulitin mo lang yun. And of course, nag-i-increase to. So we have squared here because compared to 1 here. Okay, and so on. Okay, so we can compare this term by term. Kasi kung mapapansin nyo, b sub 1 to, b sub 1 to. So this whole thing could be compared dito sa y minus y sub 0. Kasi ano na naman, di ba? Coefficient lang ito. And since para siyang polynomial, we can compare them. And then b sub 2 is this one. And then y minus y sub 0 squared can be compared to this one. So let's try that. So makakuha natin. So tingnan naman natin sa taas. We have okay, itong una B1 times y minus y sub 0. Okay? That is 1. Okay? Then next ito, magiging b sub 1 times a sub 1 x, sorry, minus x sub 0. Okay? And since wala namang ibang power dito, kahit ito lang una, i-compare natin. So we have b sub 1, a sub 1 should be equal to 1. Tama? Kasi same lang naman dito. So we have this one. And then, by manipulating this expression, we have b sub 1 is equal to 1 over a sub 1. This one. Okay, and the next one, medyo malilito. Baka yung kayo malilito. We have multiply natin to. So sa second term, we have b sub 2. Kumpara natin sa buong yon, we have b, wait, di ba? Sorry. Okay. Doon sa unang ginawa natin, wala tayong kinumpare na pa second power. Kasi, yung unang term kasi natin dito is exponent niya ay 1. Now, look at this. We still have x squared here. So we have to compare b1 times a sub 2. And dito sa kabila, ano yung makukuhanan mo ng second power? Wait, dito yan. So you have, wait lang. Oh, sorry. Nalilito rin ako. May square tayo dito eh. So if we square the whole term, ito pala yung magiging squared. Tama? Kasi ito magiging to the fourth na. Okay, sorry. So now we have b2. I-square mo yun. b2a1 squared. Ayun. So ang term dito na may power, so power of 2 is b1 times a sub 2 plus b sub 2 a sub 1 squared. Okay? So now, ikumpara natin. That should be equal to 0. Bakit? Kasi kung titignan nyo dito sa kabilang side, wala ka namang x minus x sub 0. Okay? We're comparing that to that. Medyo weird lang kasi no, bakit yung expansion ng x minus x sub 0 ay may x minus x sub 0 squared. Of course, that is because yung definition natin ng power series. Okay? So yan. So if you do that, we have this expression. Okay? And so on. So medyo mahaba pag ilalagay pa natin iba. So let's just leave it at that. Okay. So there are another example here. Another set of examples. So let's have this Langevin theory of paramagnetism. So for the magnetic polarization, so polarization is defined by P. Well, let's say along some dimension, let's say X. So it has this expression, quantity, constant C times hyperbolic cosine of X over hyperbolic sine of X minus 1 over X. So we can expand this function, P of X, as a power series for small x. We can use Maclaurin series expansion. So if you recall, usually we call sinh and cosh, but we can just call it also hyperbolic cosine and hyperbolic sine. So if we can write these function as in their exponential form. So hyperbolic sine of x is equal to e raised to x minus e raised to negative x over 2. And hyperbolic cosine of x is equal to e raised to x plus e raised to minus x over 2. So nakaiba lang sila dito. So ito ay minus, ito ay plus. Okay? So let's use, we have two methods in order to do this. Una ito. So method 1, recall that the derivative ng sinh of x is cosh x. And then the derivative ng cos x with respect to x is sinh x. So, yun lang yan. Of course, siguro alam nyo na to dahil sa 50 series. Kung hindi, tandaan nyo na lang dito. Okay? So, let's use the Maclaurin series expansion for these two functions. So, gagayahin natin Maclaurin, no? Tandaan nyo. Paano ba yan? Una is f of 0. So, kung cos siya, papalitan mo ng 0 yun. Dito, no? Palitan mo ng 0. Ano mangyayari? 1 e raised to 0 minus e raised to 0 over 2. 1 minus, well, this is 0. Sorry, you have to take the derivative first. Kasi this is wait lang. Maclaurin natin kasi f of 0. Prime of 0. So, hindi. So, this should be sorry. Sorry. This should be cos. Kasi f of 0. So, plus dapat. Ito dapat titin natin. Sorry, guys. So, this is e raised to 0 plus e raised to 0 over 2 is 2, sorry. 1 plus 1 over 2 is 1. So, we have 1. Okay? Then next is x times f prime of 0. So, ang first derivative niya ay sinh. So, ayan. Times x. And so on. Okay? Kaya nyo na isulat yan. So, kung mapapansin nyo, if you evaluate the sinh at 0, magiging 0 lang yan. Because we have shown here, magiging minus to. Magiging 0. So, mawawala lahat yan. Sorry, not this one. This one. So, ang matitira sa iyo ay mga even powers. So, we have 1 plus x squared over 2 factorial plus x to the 4 over 4 factorial. So, general form niya ay ito. Kung mapapansin nyo, para siyang cosine. However, tandaan nyo, ang cosine ay alternating. So, this is different. So, this is para siyang absolute value noong cosine into the series expression ng cosine. Okay? So, now for sinh, ganun lang din. So, take the f of 0. So, ang sinh of 0 is 0. Wala na yun. Next term is x times first derivative, which is cos. So, kung mapapansin nyo ulit, mawawala yung mga sinh ulit, no? Kasi ang sinh of 0 is 0. So, matitira sa'yo lahat ng may cos or add number ng power. So, we have ito. And this is similar lang din sa sine. However, this is again, hindi siya alternating. Okay? So, for small x, we can show na ang hyperbolic cosine is 1 plus x squared over 2 factorial. And sinh is approximately x. So, thus, pwede natin isulat, no? Sulat natin to as this one. And sinh as this one. And then, matitira sa atin ito. For small x nga, ayan. No? Kasi kung mapapansin nyo, pag pinalitan mo ng maliit na value, yung x, essentially, ma-approximate mo na siya ng ganyan. Okay? So, method 2, medyo mahaba siya. Yung ginamit kasi natin sa taas, we have to get the yung Maclaurin series ng sinh mismo at saka ng cos. But since we know na ang hyperbolic sine or sinh and hyperbolic cosine or cos can be represented by these two expressions, pwede natin gamitin yan. So we already know kung ano e raised to x. Ito yan. Okay? And then we have the e raised to negative x. So papalitan mo lang naman yung x ng may negative. So ito yan. Okay? So doing that, we still get the same expression and the same for this one. So the same lang. Nakuha tayo ng sagot. And yeah, tama. Bahala kayo kung alin yung mas preferred nyo. Dito kasi at least kabisado niya na e raised to x. So method 1, you have to derive yung Maclaurin series. Okay? Okay, so yan. Sorry. So now, let's talk about binomial expansion. This is another powerful type of expansion na siguro nadaanan nyo na to sa physics. Usually, this is used to approximate some function, no? Even yung sa kinematics expression natin ng mga motion ng projectile, ng free fall, mga ganun. So let's say we have a function, f of x is equal to quantity 1 plus x raised to m. So, power, para siyang power series din. Oh, wait, sorry. I mean, yung expression natin is parang power, pero yeah, yung binomial, 1 plus x. And we want to obtain the series expansion. So using Maclaurin series, ito yan. Okay? Makukuha natin siya. So, una, f of 0. So, papalitan mo yung x ng 0. So, magiging siya 1 raised to m is 1. Okay? And then if x, if for the second term, we have x times f prime of 0. First derivative niya ay m times 1 plus x raised to m minus 1. Now, evaluate that at 0. Okay? Ano mangyayari? Pag pinata mo ng 0 yung x, magiging m times x raised to m minus 1. And kung x naman yun, ano pwede mangyari? We can just write, we can just write yung exponent as 1. So we have m, x. And then second derivative, making m minus 1 lang. Then we still have yung x natin magiging x squared over 2 factorial. Dahil yun dito. Okay? And so on. So generally, you have this. Okay? So medyo nakakalito siya. So we have m and n. We have to take note here, kung mapapansin nyo, meron tayong mahaba expression, yung general niya, which is m times m minus 1 and so on. Kung mapapansin nyo, this is a factorial notation, no? Kasi you have m times m minus 1. Susunod yan, m minus 2. This is m factorial. However, you have to take note, we still have n here. So, in general, we can write this as, kasi meron pa tayo n factorial sa baba, di ba? This particular factorial. So, yan na lang mga intandaan nyo. And this is, kung familiar pa kayo sa discussion before sa combinatorics or statistics, this is the, this is permutation. Okay? So, yun yung nasa taas. However, we still have n factorial sa baba. So, may n factorial pa tayo nadagdag. And this is combination. Okay? So, ibig sabihin, we can write this, yung term here generally using this expression and just use power of x. So, therefore, yung power series natin ay ito. Yan. So, yung a sub n natin is itong buong ito. Yan. Okay? So, using ratio test, we can show na ito yung ano niya, limit. So, we have two limits here. Evaluate the first limit, we can show as n approaches infinity, magiging 0. Huwag niyo pansinin yung m kasi n lang naman titignan natin. Magiging 0 to. Kasi lalaki ng lalaki to, magiging infinite. So, 0. Meaning, ang ibig sabihin nun, yung unang term natin ay valid for all m. Tama? From negative infinity to infinity. Now, evaluate yung second. Meron tayong x dito, no? We take the absolute value of that. Magiging ganito. So, meaning, valid siya between negative 1 and 1 lang. So, however, we have to further check. Diba? Yung ginagawa natin. For x is equal to 1, magiging 2 raised to m. And this is a finite number. Okay? We can also test for the convergence, no? For x equals 1, papalitan mo lang ng 1 nito, so magiging Ganito yung expression natin. Tandaan nyo yung coefficient lang, no, which is m, sorry, ito na lang, given by this. And then mag-add ka ng 1 sa n. Sa n lang, huwag sa m. Yan, so may ito quantity n plus 1 and n plus 1. So, manipulating that, you will have this. And you can see, if you take the limit, as n approaches infinity, so divide everything by n, ang titira sa'yo ay negative 1. And that is less than 1. So, ibig sabihin, pwede. Okay? So, if negative 1 naman yung x, magiging 0. Tama? Mawawala ito eh. So, finite pa rin. Therefore, convergent yung series natin from negative 1 to 1. So, we can analyze this further. So, we have to show here, of course, tingnan nyo yung, yung factorial natin is m factorial over m minus 1 factorial. M factorial, no? It makes sense na yung m should be greater than or equal to n kasi hindi mo pwede negative. Okay? So that is to avoid the negative factorial. So therefore, nagdeterminate yung series natin at n equals m. Tama? Kasi pagdating doon sa, kasi yung bounds natin, tandaan nyo, is n to infinity. However, we have shown na at n equals m, here, magsi-0, magdeterminate na yung series natin. So, ito na yung binomial expansion. So, pinakaiba lang naman niya, tinatala natin ito ng m instead of infinity. So, ito yung general expression niya. However, combination could also be written like this. So, m taken n. Ito lang yan. M minus 1 factorial. So, m minus n factorial over n factorial. Same as that. Okay? We have another example here. But I guess I leave that to you to do. So, we have the expression for the energy. This is a relativistic energy, no? Kung familiar pa kayo sa Einstein's theory of relativity. Special relativity. So if we have rest mass m sub 0, velocity v and c as the speed of light, you can use the binomial series or Maclaurin series expansion and compare that to the classical kinetic energy, which is 1/2 mv squared. So using Maclaurin, we can show that ito yung expansion niya and you can compare. Okay? Ang ibig lang sabihin nito, for velocity much less than speed of light, we can see na yung relativistic kinetic energy, kasi ito yung expression niya eh. So sobrang liit daw ng velocity here, this whole thing goes to 0 approximately. So you still get to the classical kinetic. So yan lang yung pinapakita niyan. Okay? So we have some more here. For example, this is the inverse sign. So yeah, let's do this kasi so far nag-discuss na natin trigo function. So let's find the series expansion for inverse sine of x. So in this case, we have to let some variable kasi wala naman tayong explicit definition for that. So let y is equal to the inverse sine of x, and this implies that sine of y is equal to x. Okay? So since this is trigo function, we can use a unit circle. So, and show na if you take, halimbawa, derivative ng sine x, derivative mo, no? Derivative of sine y is equal to dx. And we have, ano nangyari? This is cosine y dy. Okay? So, equal to dx. So, we have dy over dx is equal to 1 over cosine y. And since for unit circle, we have 1 over square root of 1 minus x squared. Okay? So, ngayon, medyo tricky na to, no? Para ma-solve natin yung y, tandaan nyo, this is yung y ang hinahanap natin, no? Itong buong ito. Okay? We can parameterize. So, since integral, para makuha mo yung buo, you have to integrate the whole thing. So parameterize natin, let's use t, and we have to evaluate the dt from 0 to x. Okay, so ito na yung magiging expression niya. Okay, so now, medyo hindi to madaling i-integrate basta-basta. So the easier way is to use expansion. So tandaan nyo, this is very similar sa binomial. Kasi kung tatandaan nyo, 1 over square root of 1 minus t squared, it's just equal to, 1 over 1 minus t raised to negative 2. Oh, sorry. Mali. T squared raised to negative 1/2. Okay? Sorry, 1/2 lang. Kasi nasa baba na pala siya. So, pag itataas natin siya, square root naman siya, di ba? Ito siyang 1 plus t squared raised to negative 1/2. Yan. So, yan. So, this is essentially similar to sa discuss natin na 1 plus x raised to m. In this case, yung x natin is t squared. Yung m natin is negative 1/2. Okay? Let's use the Maclaurin series or binomial series expansion. So, ito yung makukuha natin. So, i-verify nyo lang to. And if you do that, you have this expression, 1 plus 1/2 t squared plus 3 over 8t to the 4th plus 5 over 16t to the 6th. So, yan, mas madaling integrate ito. Papalit mo itong buong to dito. Okay, so you can use at least 4 terms lang. Okay na yan. So, since integration lang to, dahil lang integrate, dahil nasa taas lang yung t. You have this, and palitan mo, evaluate mo from 0 to x. Since kung nasa taas lang yung evaluate natin, mawawala na yung lahat ng pinalitan mo 0, eh matitira lang yung mga pinalitan mo ng x. So, you have x plus 1 over 6, x cubed, plus 3 over 4t over x to the 5th, and so on. So, yan ang series expansion ng inverse sign. Hindi siya explicit gawin, no? Kasi kailangan mo muna i-define mo na yung inverse. Kasi inverse ito. So, hindi siya kagaya ng normal sine and cosine. Okay? Karanag? So, this is just another general remark for Taylor series expansion. This is not really included sa magiging exam or problem set nyo, but it's also good to show kung paano. So, yung mga expansion na pinakita natin is good for one function of one variable. So, what if we are dealing with 2 independent variables? So, initially, for one variable, we have this Taylor series expansion. Okay? So, we can further extend this to 2 variables, let's say f of x, y. So, magiging ganito siya. Medyo mahaba to, guys. So, instead of evaluating the whole derivative, you have to take the partial. Kasi you have your function depends on x and y. So, yung una kasi sa Taylor series pag one variable, f of a, b, a lang. Since we have to interval na, we have f of a, b. And then, next is x minus a. Parang ganito lang din yan. Times, ngayon, partial derivative na lang. Ito kasi bond derivative. And then, since may y tayo, y minus b, partial derivative na with respect to y. So, this whole thing is galing lang din dito. And then, yung susunod, 1 over 2 factorial, dito galing. And mahaba na expression. So, hindi ko na i-discuss yung buong yan. So, makikita nyo na may pattern. Okay? So, yan. So, yeah. I-discuss ko na lang itong next section natin, which is elliptical integral sa next lecture. So, medyo mahaba yung power series. But kung mapapansin nyo, this is just the same as Taylor series din. And of course, yung mga series of functions natin na we have to test for uniform or absolute convergence, etc. Makita natin yung validity ng mga functions natin, even if we represent them in terms of power series form. Okay? So, thank you guys sa pakikinig. Hopefully, may natutunan. Kapag may question again at nalilito kayo, let's just book a consultation and we will discuss that para mas madali nyo maintindihan. Again, huwag kayong mahiyang mag-consult kasi gusto ko rin naman yung mga may nagko-consult kasi para makita ko rin kung paano nyo naiintindihan yung bawat lesson para ma-improve ko rin naman. So, yun lang muna and hope to see you sa susunod na lecture. Thank you guys. Stay safe.